Hey guys, welcome to week number 5 of the Ace Your IB Math Exams in 5 in 10 weeks challenge. This is week number 5. If you do not know me, I'm Bruno, the IB Math teacher. I've worked as the head of the mathematics department in one of the most prestigious IB schools in Brazil, also the HL math teacher, and I'm also an IB math examiner. And for this May 2026 cohort, I've decided to launch you can call it a course or a challenge, the Ace Your IB Math Exams in 10 weeks challenge, where in each week we tackle one question from each one of the 5 different IB math topics: number and algebra, functions, trig, statistics, and calculus, with challenging IB math questions as a way to mimic what you're going to face a few weeks from now. You can find all materials the past few weeks, the YouTube videos and the PDFs in the description of this video right here. Everything is for free. And I'll also want to encourage you to share that with your colleagues so you guys can study together. Given that studying together is much more fun than studying by yourself. So let's get to it. Let's get through week number 5 of the Ace Your IB Math Exams in 10 weeks. For this first exercise, we have a simple binomial expansion. In question A, we have 1 over x squared plus 3x to the 4th power. Now, whenever you have a power which is not as high as, for example, 7, 8 or something like that, if it's up to the 4th power, for example, this is a perfect place to use Pascal's triangle, because it's easy to build Pascal's triangle all the way down to the 4th row. And by doing so, you get to see the binomial coefficients, which makes this a simple process. We use the binomial coefficients. We take our a term, and a refers to the fact that we're expanding a plus b to the n. And we multiply it by the binomial coefficients from the exponent that we see here all the way down to 0. And then we do the same thing for b, but starting from the right and working our way to the left. And these guys, they're being added. Do remember that you have the formula for this binomial expansion in your formula booklet. So we have over here 1 over x to the 8th, 1 over x to the 6th, 1 over x to the 4th, and 1 over x squared. Now over here, and by the way, there should be a 0 here. Over here we have 81 x to the 4th, 27 x cubed, 9x squared, 3x, and then just 1 over here. As you simplify, you should get 1 over x to the 8th plus 12x over x to the 6th, which is of course the same thing as 12x to the 5th, plus we have 9 times 6, 54, x squared over x to the 4th, which is 1 over x squared, plus 27 times 4, 108, x cubed over x squared, which is just x, plus 81x to the 4th. And that is it. This is the full expansion of 1 over x squared plus 3x to the 4th power. Now on to question B. And do notice the word hence here. Hence find the term in x to the 4th in 2 plus x cubed times what we had previously. Instead of writing this, we can replace 1 over x squared plus 3x to the 4th by the expansion that we got. And what's the advantage of that? Well, if we do so, we get to see which combinations, which products will generate a term in x to the 4th. And there are 2. You get a term in x to the 4th if you multiply x cubed by 108x, which gives us 108x to the 4th. And you also get it by multiplying 2 by 81x to the 4th. Do notice that there's no other combination that would produce an x to the 4th. Therefore, the final answer is 108x to the 4th plus 162x to the 4th, which is 270x to the 4th. Now on to the next exercise. In exercise number 2, we have a mix between a functions type of exercise with calculus. There's a portion here, or a part of this exercise, in which we're going to need to use concepts of calculus. But this is not a particularly hard exercise. Let's tackle it. So we have a function f of x, 1 over 6 x cubed plus 1 over 4 x squared minus 3x, and part of the graph of this function is shown over here. So we see that it crosses the point 2 comma negative 11 over 3, which he's labeling it point B, and we need to find the coordinates of point A, which is a maximum point. Now this is where calculus comes into play. How do we find maxes and mins? We take the first derivative and make it equal to 0, and if we do so, given that we have a cubic here, we're going to get a second degree equation, which is completely fine. We can use either the quadratic formula or sum and product to solve. Sum and product, of course, being the faster method. So let's first differentiate this. F prime of x equals 1 over 6 3x squared, which is the derivative of x cubed, plus 1 over 4 times the derivative of x squared, which is 2x, minus 3. And that is it. We make this equal to 0, which means that you can first simplify these by 3 and by 2, and then multiply both sides of this equation by 2, which gives you x squared plus x minus 6, which is 0. Now we get x minus 2 and x plus 3 using sum and product. Now whenever we have a product which is equal to 0, either the first term is 0 or the second one. Now the first term being 0, we already knew that would happen because we can see that we have a min when x is equal to 2. So that's not new, that's actually expected. But the other answer is x equals negative 3, which is the x value of this point over here. Now, the way to find the y value is, of course, by plugging it into the original equation. And if you plug in negative 3 into the original equation, you get 1 over 6 times times negative 27 plus 1 over 4 times 9 now, plus 9, which is 27 over 4. So this is 27 over 4, and the coordinates are negative 3, 27 over 4. One exercise down, 2 more to go. We have question B. Now we're tackling transformations. We are, for BI, translating the function according to this vector. What does this vector represent? A translation vector CD represents a vertical shift up by d units, and of course if d is negative, that means that it's going to be a vertical shift down, and a horizontal shift c units to the right. So basically what we have here is f of x minus c plus d, and if we're taking this point, point B, and shifting it to the right by 3 units, that means that the new x coordinates will be 5. And if we go down by 2 units, so translate it down 2 units, that means that we get a new y coordinate, negative 11 over 3 minus 2, which is equal to negative 17 over 3. Now in the last one, we want the image of B after reflecting in the y-axis or over the y-axis, followed by a horizontal stretch with scale factor 1/3. Now to reflect it over the y-axis, we do f of negative x, and with the horizontal stretch with a scale factor of 1/3, we multiply the x values by 3. Therefore, we have f of negative 3x. Careful, because this is counterintuitive. A horizontal stretch with a scale factor of 1/3, and this is from the IB Math course guide, means that you're multiplying x by 3, so f of 3x. In addition to that, we have the negative sign, which is due to the reflection across the y-axis. And what happens to the point? Well, whatever we do with the x values, we actually do the opposite, which in this case, instead of multiplying the x value by negative 3, we're going to divide it by negative 3. So b prime, which is the image of b, is negative 2/3, and the y value doesn't change, negative 11 over 3. So a little bit more complicated than what you were probably expecting. Now let's jump to the next exercise. Alright, so for question number 3, as usual, we have a trick question, one that involves, in this case, the sine rule, the cosine rule, and finding areas of triangles. So this may be a little bit harder than the usual type of sine and cosine rules exercises. So let's tackle it. The diagram below shows a quadrilateral ABCD, and we have all the side lengths over here and all the angles over here. They are marked in this diagram below. Now the first thing we need to do is to use the cosine rule in triangle ABC to find AC. And how does it work? Well, we can see that we have cosine of x here, therefore the side that we're going to start with, which is opposite to that angle, is AC. AC squared equals 6 squared plus 5 squared minus 2 times 6 times 5 cosine of x. And we can see cosine of x over here and over here. So AC squared is 36 plus 25 minus 60 cos. Therefore, AC, which should be positive, is the root of 61 minus 60 cosine of x. So we did find it. We did find AC as the root of 61 minus 60 cosine of x. Now we're going to get another expression for this same side AC, but using now the sine rule in the same triangle. And we're going to use this angle with this side and this angle with this side, given that we don't have this angle, so we cannot use this side with it. So we have sine of x over its opposite side equals sine of 40 over its opposite side as well. So AC is 5 times sine of x over sine of 40 degrees. Now the idea of finding AC in two different ways is for us to build an equation in which by plugging it into our GDCs we can solve for x, which is the angle opposite to AC, and that's exactly what we're going to do. So given that AC is equal to AC, the root of 61 minus 60 cosine of x is equal to 5 sine of x over sine of 40. And by plugging this into our GDCs, and let me change this to degrees, we have in the numeric solver the root of 61 minus 60 cosine of x minus 5 sine of x over sine of 40 equal to 0. Now do notice that I moved everything to the same side here. Now one thing that we know is that this angle is acute. Therefore, we're going to search for the answer between 0 and 90 degrees. And we can guess it at 60, for example, and we get 89.5 degrees. Now for this angle, we have our AC as the root of 61 minus 60 cos of 89.5, which is approximately 7.78 centimeters. And now we can jump to question D, which is to find the area of this quadrilateral. We're going to split it into, it's already split actually, into two triangles, and we're going to find the area of these two individual triangles and add them to get the result. Given that over here we have the area as half AB sine C, which means sine x 89.5, and in this one half times A times B times the sine of an angle that we're still yet to find. When we add these two, we get the total area. Now let's find angle Y. By applying the cosine rule over here, we have AC squared equal to AD squared plus DC squared minus 2 times 5 times 5 cosine of Y. We get a cosine of Y equal to negative 0.2100, which means that Y, which is the inverse cos or our cos of that Y is approximately 102 degrees, which means that this is 102, and the total area, it is approximately 27.2 centimeters squared. Now careful with the rounding, otherwise you're going to get a different final answer, one that is off by 0.1 or 0.2, something like that. Now let's jump to the next exercise. Alright, let's get to exercise number 4, one that involves normal distributions with conditional probability also as one of the last questions. So let's take a look. We have the weights of watermelons being distributed normally with a mean of 12.3 kilograms. And in this case, notice that we were not given the standard deviation. Now, the probability that a watermelon weighs less than 9 kilos is 0.15. In question A, we're asked to write down the probability that a watermelon weighs more than 15.6. And it seems like we're not going to be able to manage that or to do that given that we do not have the standard deviation. Notice the command term, write down. Write down means it shouldn't take any calculation whatsoever for you to determine the answer for this question. And how is that the case? Well, by sketching a bell curve and illustrating the mean over here in the middle, as it should be, of course, as 12.3 kilograms, or let me just write 12.3. One thing that we know is that the probability of finding a watermelon which weighs less than 9 kilograms is 0.15. So let's say that this red line, it represents 9 kilograms, and the probability, meaning the area over here of being less than 9, is 0.15. Now, due to the symmetry of a normal distribution and noticing that this gap over here is 3.3 kilograms, if we represent that gap to the right now, we should get the same area to the right, which means 0.15. Now, what is 12.3 plus this step of 3.3 to the right, or the addition of 12.3 plus 3.3? Well, that gives us the 15.6 that we were looking for in the first place, or that was mentioned in the first place by the exercise. Therefore, this probability right here is 0.15. Now, how should I write this in an exam? If it's a write down command, you can just state what the probability is. So 0.15 is already enough. Now let's move to the next question. Find the standardized value Z for 9 kilograms, meaning the z-score of a standard normal distribution that has the same probability of this 9 kilograms, meaning if you take the probability from negative infinity to this z-score in a normal standard normal distribution, that probability will be the same as the probability from negative infinity to 9 in this distribution right here. Anything that's a z-score, I'm going to represent in this color purple. So I'm going to drag all of these lines down. I'm actually going to change this color to be a little bit different. There we go. Anything that's in blue, again, represents a standard normal distribution, one with a mean of 0 and a standard deviation of 1, which means that the z-score of this mean, or any mean, it is always equal to 0. Now we need to find this z-score right here, which, as we can see, it's going to be negative. It's to the left of 0. Now we're representing this area 0.15 over here in our standard normal distribution, one that has a mean of 0 and standard deviation of 1. And we need to find this value, which is going to correspond to the z-score that gives us a probability of 0.15 to the left using your GDC. And in this case, I'm using the TI-84 to do it. The area being 0.15, the mean 0, standard deviation 1, and the tail to the left, we get as the z-score negative 1.03643 ... Now, how do we convert the z-score back to our original variable, which is measuring the weight of these watermelons? We use z-score is x minus mean over the standard deviation. We do not have the standard deviation, and by the way, we are already answering B to I, but we will find it through this equation. We know the z-score, we know the x value associated to this z-score, which is 9. We know the mean of this distribution, 12.3, and we need to find the standard deviation. When solving this equation, we get 3.183 ... So B to I, this is done. Now, next part. To be selected to be sold in a local market, a watermelon's weight must be within 1.2 standard deviations from the mean, which means from negative 1.2 standard deviation from the mean to the left, all the way to 1.2 standard deviations from the mean to the right, which means greater than the mean. Now, what is 1.2 standard deviations? This is 1.2 times the value that we got previously, so 3.82. Therefore, 3.82 to the right and 3.82 to the left, given that the center is 12.3, means from 8.48 and 16.1. So we can write it as an interval. 8.48 is less than W, which is less than 16.1. And let me actually change this W to X because we are calling the weights of watermelons X. So there you go. This is the interval. So this is done. Now let's say you select at random a watermelon. What is the probability that it can be sold in a supermarket? Well, that pretty much means finding the area under this curve between 8.48 and 16.1, and we can find that through our GDCs. This is a normal CDF, and we get 0.770 rounded to 3 significant figures. Now we jump to the last question. Of the watermelons on the harvest, 30% of them are seeded ones, and from these, 60% are sold on the local market. Do notice that we're talking about the same watermelons on this harvest. Now, given that a watermelon selected at random is sold in the local market, find the probability that it is a seeded watermelon. Now, you're probably identifying a conditional probability over here, given that was used, these two words, given that, or this expression, and this means that a condition was given, some piece of information was given. We are talking about watermelons that got sold in the local supermarket. How do we use conditional probability? The probability of A given B is equal to P of A and B over P of B. How do we translate this to this specific exercise? Given that the watermelon is sold in the local market, what is the probability that it's a seeded one? Well, it is the probability that it's a seeded that got sold in the market over the probability that it gets sold in the market. And notice that we have the denominator already from question C2I, which is 0.770. However, when addressing this question, you cannot round just yet. You need to use 0.769 A3 ... And what is the probability that it's seeded and sold? Well, 30% of them are seeded, and from these, 60% are sold. Therefore, the numerator is 0.3 times 0.6. When you divide 0.3 times 0.6 by 0.769 ... you get, rounded to 3SF, 0.234. And that's it for this question. All right, so lastly, let's jump to a demanding calculus exercise. It is very rare that students get this question correct from start to finish, so 100% of this question correct. Let's see why that's the case. We have two functions, g of x and h of x, and we have in this table certain values for these functions. So for example, g of 3 is equal to 1, and g prime, so information about its derivative as well, at 3 equal to 4, and so on and so forth. And we need to find, first of all, h of g of 3, which is a composite function, and g of h negative 1 of 3. These two do not involve the derivative. However, you do need to know how to find them in your table, or in this table. Now, what is h of g of 3, starting from ai? First of all, g of 3, it is equal to 1. So this value over here, it is 1. Then we're left with h of 1. And h of 1 is equal to 12. So this is 12. Now let's tackle a more challenging one. What is h negative 1 of 3? What you're asking there is, what is the input if the output of h is equal to 3? Meaning, we want the output of h to be equal to 3. So we're asking, what is the x value that gives us that output? And that is equal to 5. Remember that we're talking about inverse functions. So it's not inputting 3 into h, but actually asking what was the input there that gave us 3 as the answer. And that is equal to 5. So we have g of 5, which is negative 3. And that's it. The easier part is done. Now on to the hardest part. Find the equation of the tangent line to the graph of f of x at x equals 5 if this function that we're creating is a product of g and h, or it's a composite function. So we have these two different scenarios. Let's start with bi. When x is equal to 5, we have f of 5 equal to g of 5 times h of 5, which is equal to negative 3 times 3, which is negative 9. Now we know that this function crosses the point 5, negative 9. And in order to find the tangent to that curve at that point, we not only need the point itself, which we have already, but also the slope of this tangent line. And to find the slope, we need to find the derivative of f. Given that f is a product between g and h, we need to use the product rule for that. So let's apply the product rule for f of x first. Now f prime of x is g prime of x times h of x plus g of x times h prime of x. This is us applying the product rule, which means that f prime of 5, which is the slope of that blue line, it is equal to g prime of 5, which is 6, times h of 5, which is 3, plus g of 5, which is negative 3, times h prime of 5, which is negative 2. So we get 24 as the slope of this tangent line. Therefore, the equation of the line is 24x plus b, and if we replace the point over here, we can find b. So b is negative 129, which means that the final equation is 24x minus 129. Now let's jump to the second part, where f of x is a composition between g and h, g of h in this case. Now, if we have a composite function, we need to apply the chain rule now to find the derivative of f and to replace the values for when x is equal to 5. So how do we apply the chain rule? F prime of x is g prime of h of x times h prime of x, which means that f prime of 5 is g prime of h of 5 times h prime of 5. H of 5, it is equal to 3, and g prime of 3, that is equal to 4. So we have 4 times h prime of 5, which is negative 2. So we have negative 8 as a result, or as the result, as the slope. Now, we never found f of 5 for this case, so let's calculate it right now. F of 5 is g of h of 5, which is g of 3, which is equal to 1. Therefore, for this particular curve, the point of tangency is 5, 1. So we have y equals negative 8x plus b, and by replacing that point, we get b equal to 41. Therefore, the final equation is negative 8x plus 41. And that's it. All right, so that's it for week number 5 of the ACE Your IB Math exams in 10 weeks. I'll see you on the next one. If you've missed any day, any PDF, any YouTube video, you can find all of those in the description of this video. I'll see you on the next one.